Hello everyone, I'm Anant Mittal, author of the book TMUA Simplified. So I've started this series, Questions of the Day. Today I'm bringing two more questions which are based on necessary and sufficient condition, a part of paper 2. So let's start. Now the question says, let A and B be real numbers. The equation x square plus ax plus b equals to 0 has two distinct positive real roots. Which of the following is necessary and sufficient condition on A and B? Right? Okay. So necessary and sufficient condition means that a condition which ensures that the roots are real and positive, and this that should be the only condition which ensures that roots are real and both positive. That's how we look at this question, right? So sufficient means necessary means okay. It um, it leads to roots being real and positive, but does not ensure that roots are real and both positive. Sufficient is it ensures, but there can be other condition also which ensures that roots are real, distinct positive real roots, right? So that these are the differences between necessary and sufficient and only necessary, right? So let's understand. So I know the keywords here are real and both positive and distinct. So b square minus 4ac, the discriminant should be greater than 0. Here the discriminant will be a square minus 4b greater than 0. Now, if I solve it on a number line, so I know the roots are minus 2 root b and plus 2 root b. Now, this such inequality will be solved by plus minus plus. So I know that a will either be greater than 2 root b or a will be less than minus 2 root b. Now, also both the roots are positive. So I have to ensure that sum of roots needs to be greater than 0 and product of roots also needs to be greater than 0. So here the sum of roots will be from the equation minus a greater than 0 ensures a less than 0 and product is b greater than 0. So a greater than 0, b greater than 0 and these two conditions together tells me that both roots are positive and both the roots are positive and real. Now let's look at the option. Now this ensures that roots are positive, but it does not tell me that both roots are real. For example, if I take a as 1, b as 1, so or a as minus 1 and b as 1, right? So it will not ensure that the roots are real. It will give me imaginary roots, this equation, right? Now a square greater than 4b, b greater than 0, again does not ensure that a is less than 0. As if b is 1 and a is 3, then also this is satisfied. Then also it is satisfied because 9 is greater than 4. If I put a as 3 and b as 1, so I'll get 9 greater than 4. So this does not ensure that a is negative. Now this condition says a is negative, but it does not ensure that b is positive. Because if I take a as minus 3 and b as minus 1, right, or a as minus 2 and b as minus 2. So 4 is greater than minus 8, yes. So for negative value also it's satisfied. But if I look at this condition, now since b is positive, this is one of the branches. This is one of the branches to ensure that the roots are real. Now, since b is positive, which I have to take, if I take any positive value of b here, a will definitely be negative. So this ensures that roots are real as well as b is positive and a is negative. So this becomes my correct answer. So answer is D. E cannot be the answer because there is a equality. Roots are distinct, so I cannot take a equality. Right. Let's move on to the next. Now this gives me P. Let x and y be real numbers and consider the statements P is such that x plus y is greater than 2 and xy is greater than 1. Q is such that x is greater than 1 and y is greater than 1. Which of the following is true? P is necessary and sufficient for Q. Let's understand, does P ensures Q? If P ensures Q, then it's a sufficient condition. And if Q ensures P, then P is a necessary condition for Q. Right? P ensures Q, then P is a sufficient condition for Q. If Q ensures P, then P is a necessary condition for Q. This is how it works. Now let's understand, x plus y greater than 2 and xy greater than 1. Does it ensure that these two are equal? X and y both are greater than 1? Okay. Very easily I can take a counter example. Like for example, x is 3 and y is half. So this gives me greater than 2. Of course, 3.5 is greater than 2. And 3 into half, 1.5 is also greater than 1. So very easily I can take a counter example and disprove it. So P does not ensure Q. P does not ensure Q. So that's why P is not sufficient for Q. But if you look at Q, so it says x is greater than 1, y is greater than 1. So obviously x plus y will be greater than 2 and xy will also be greater than 2. You take any number, right? Xy will be greater than 1. You take any small number, 1.1 plus 1.1 is 2.4. 1.1 into 1.1 will be 1.21, right? So this Q ensures P. So P becomes necessary for Q. So P is not sufficient, but necessary for Q. So the answer is, let's look at the option. Necessary and sufficient? No. Necessary but not sufficient. So this becomes the right answer. P is sufficient but not necessary for Q. Again, sufficient. P is not sufficient for Q. So all the sufficient cases should be removed. Now P is neither. No, it is necessary. So I have to take answer B. So these two are very similar to what questions which are very similar to what you can expect in the paper 2 of TMUA. Right? For more such questions, you can buy my book, TMUA Simplified. It covers entire theory and a lot of questions, and also video lectures, video theory lectures, and solution videos, right? Which is rarely you get in our book, and it costs you only 4,000. For which otherwise for video lectures, a lot of institute charges a lot of money, like 60 to 8, 60, between 60,000 to 1 lakh, right? So the link for if you want to buy this book, the links are in bio. So you can the books are available at Blue Rose Publications, Amazon, and Flipkart. I would prefer you to buy it from Blue Rose Publication because the delivery of the book will be swift. So look out for my videos. Keep looking, keep checking them out, and keep bringing them. Take care. Have a nice day.